say the area of this rectangular rose garden have this particular dimension, all right, and the measurement is written in meters. X is larger than 0 but less than 2 meters. And find the value of x for which the area of the garden plot is at the minimum. Now, obviously, you can use calculus to solve this, but this problem can be solved without calculus by just using your calculator. Now, what you need to do is to make sure that you pay attention to this function. That's this a here. So make sure that I have mode. Press my mode that this here is using function and that we are in real. So if this is real and function, then it's okay. Then I go to y equal. And then I type in the function. It's a bracket, so bracket. And then I have x squared, so x squared. And then plus 1, all right, close bracket. And then bracket again, 6 minus 2x, for example. All right. Here's my equation, and x here has to go from 0 to 2. So I make sure that I go now to the window, and that x minimum here, because I want to see 0, so I'm going to go slightly before 0, so it's -1. And then the x maximum, I'm going to go to 3. X scale, I'm going to use 0.5 as half of that. Y minimum, really, I don't know. I don't really know the measurement, but I believe this is the area have to be more than 1, so more than 0. So I'm going to use -1. Whereas a Y max, I'm going to put in about 15, for example, just as a try. And then I'm going to graph this. Okay, so here's my graph. So you can see that there is a maximum here and a minimum here. So now we read the question carefully. Find the value of x which the area of the garden plot is at the minimum. Now, if you're doing this for the IB, you better sketch the graph as well. So as part of your answer, here's A because it's for the area. And then here I have my x, where this is the length in meters. And up to about 2. All right, so we can find out where 2 is, for example. Calculate, I want the value, number 1, value, and put in 2, and enter. So 2 is somewhere around here. So this is 2. It goes from 0 to 2. In fact, it doesn't include 2, so it has to be an open bracket. Over here is an open circle, and here is an open circle, for example. And I have the minimum and maximum. So let's calculate the minimum and maximum here. So I could calculate, all right, there's a minimum there, minimum, right? Minimum is somewhere there. So it's from 0, left bound, to right bound somewhere around here. And then go to the gas somewhere here. All right, so this is my minimum. So over here, the answer here is about 0.184 to 3 significant figures and 5.82. Second trace for calculate, and number 4 is maximum. Left bound somewhere about 1.5. Right bound somewhere around here. And then the gas maximum is somewhere in the middle. And here we have 1.82 to 3 significant figures and 10.2, right? So now I can answer the question, find the value of x for which the area of the garden plot is at the minimum. Well, here's the minimum, and the value of x is this. So for the part A, x is roughly 0.184 meters in length. B, find the maximum area of the garden plot. The maximum area here is this. So the A max is roughly 10.2 meter square. So here the unit is meter square. All right. Next, C. Calculate the length of the rose garden when the area is at the maximum. So there's this one. So x here is roughly 1.82 meters to 3 SF. So that's it. You can see this question is relatively easy to do. All you need to do is type everything into a calculator, sketch a graph, an appropriate graph, and label it accordingly, and then pick the answer for your question.